Hello everyone and welcome to my channel, and in today's video let's discuss the 14 most important rate measurement problems from AOD chapter for our math board exams, and this is a compilation of 14 most important problems. So let's look at the first problem here. Question 1 says a balloon which always remains spherical has a variable diameter of 3 by 2, 2x plus 1. Find the rate of change of its volume with respect to x. So let's assume v as the volume of the sphere, the balloon, and r as the radius. So we know that the volume of a sphere is 4 by 3 pi r cube. Now it is given to us the diameter, that is d, is 3 by 2, 2x plus 1, and is of course changing with respect to x. And we know that radius is equals to diameter divided by 2. So therefore we can write the radius as 3 by 4 2x plus 1. Now substituting the value of radius, that is r, in this formula of the volume, so you keep the value here and you will get this expression, that 9 by 16 pi 2x plus 1 whole cube. Now we just need to find what? The rate of change of volume with respect to x. So what do? We differentiate v, that is volume, with respect to x. And when we differentiate that, we get this as our answer, which is 27 by 8 pi 2x plus 1 whole square. This is our answer. Question 2. The radius of a balloon is increasing at the rate of 10 centimeter per second. At what rate is the surface area of the balloon increasing when the radius is 15 centimeter? So whatever is given, we'll write that. First, we're given that the radius is changing with respect to time. So dr by dt is equals to 10 centimeter per second. And the surface area is being talked about here. So the surface area, the formula of surface area for the balloon here will be 4 pi r square. Okay. So now we will differentiate the surface area with respect to time, and we get 8 pi r dr by dt. Now the value of dr by dt is already given to us, that is 10 centimeter per second. So we will substitute that, and when we do so, we get ds by dt as 80 pi r. Now it has also been given to us that we need to find the rate of change in surface area with respect to time when the radius is 15 centimeter. So since the value of r has also been given to us, we will now substitute the value of r, and that will make it 80 pi into 15, which will give us 1200 pi centimeter square per second. The answer. This is per second, alright? Please note that. Now moving on to question 3. A particle moves along the curve y is equals to 2 by 3 x cube plus 1. Now find the points on the curve at which the y coordinate is changing twice as fast as the x coordinate. So now it has been given to us that y is equals to 2 by 3 x cube plus 1, and the change in y coordinate, that is dy, is equals to 2 times the change in the x coordinate, that is dy is equals to 2 dx, right? And we can also write this as dy by dx is equals to 2. Now moving ahead, now we're told to find a point, at which dy by dx is equals to 2 in the equation that is given in the question, this equation. So solution, first you will find differentiation of y with respect to x. So when we do dy by dx, we get 2x square. Now the value of dy by dx has been given to us in the question as 2. So we will put 2 over here. So 2x square is equals to 2 because dy by dx is equals to 2. Now after solving this, we get the value of x, that is either plus 1 or minus 1 because of the under root sign. So plus 1 or minus 1. Now keeping both the values in this equation, that has been given to us in the question. Now if we keep the value of plus 1, and then we will keep the value of minus 1, and whatever corresponding value of y we get, we will note it down over here. So when we take it as 1, we get 5 by 3, y will be 5 by 3, and when we take the value of x as minus 1, we will get y is equals to 1 by 3. And therefore, when we write this as ordered pair, in the form of ordered pair in parentheses, these are the required points on that curve. Moving on to question number 4. Sand is pouring from a pipe at the rate of 12 centimeter cube per second. The falling sand forms a cone on the ground in such a way that the height of the cone is always 1/6 of the radius of the base. How fast is the height of the sand cone increasing when the height is 4 centimeter? So now let's assume v as the volume of the cone, r as its radius, and h as its height. And we know that the volume of a cone is given by this formula, that is v is equals to 1 by 3 pi r square h. Now in the question it is always it is also been given that the height of the cone is always 1/6 of the radius, that is h is equals to 1 by 6 into r. Now when we simplify this, we could write this as r is equals to 6h, right? Now substitute this value here in this formula of the volume. Now why do I do this? Why am I doing this? Because you see, we're talking about how fast the height of the sand cone is increasing. So that means we need this equation, we need the volume to be only in the terms of the height, so that we can easily find the height. So that is why we are keeping we're not substituting the value of h, but we are substituting the value of r. So here when we do that, we get the volume as 12 pi h cube. Moving ahead, now you see the rate of change of volume with respect to time, that is dv by dt. You see dv by dt here, we will now differentiate this equation. So here we get 12x dh d upon dh, and then you get h cube, and then you get this. Now when you further simplify that, you will get this as your answer. Now it has been given to us in the question that dv by dt, the value of dv by dt is 12 centimeter cube per second, and the height has also been given to us as 4. Now substituting all these values, you will get 1 by 48 pi as the answer. So the height of the sand cone, when it is 4 centimeters, it's increasing at the rate of 1 by 48 pi centimeter per second. Question number 5 says a particle moves along the curve 6y is equals to x cube plus 2. We are supposed to find the points on the curve at which the y coordinate is changing 8 times as fast as the x coordinate. So here write the equation of the given curve, right? This equation. Now differentiating both sides with respect to x. 6 dy by dt is equals to 3x square and dx by dt plus 0, because this is a constant. Now simplifying this, you get this, and now it has been given to us that the y coordinate is changing 8 times as fast as the x coordinate. So these values have also been given to us. Now thus when we substitute those values here and further simplify it, we get the value of x as plus minus 4. Now again, as we did this in the earlier question we discussed, we will keep the value of x as plus 4 once, and then as minus 4, and then we will note down the values of y corresponding values of y we get. And where do we put this value of x? In the given equation according to the question. So when we do that here, it is noted that when x is equals to plus 4, we get the value of y as 11, and when x is equals to minus 4, we get the value of y as minus 31 by 3. So hence the points required on the curve are 4, 11 and minus 4, minus 31 by 3. Moving on to the sixth question. A man 160 centimeter tall walks away from a source of light situated at the top of a pole 6 meter high at the rate of 1.1 meter per second. How fast is the length of his shadow increasing when he is 1 meter away from the pole? Now you see, it is given that the man is 160 centimeter tall and he is walking away from the source of light. So say suppose this is a source of light AB, let AB be the source of light, which is 6 meter high, 6 meter tall, and let MM be the man here who is 160 centimeter tall. Please correct here, it is 160 centimeter tall. Now they're asking us how fast is the length of his shadow increasing. So let this MS be his shadow when he is 1 meter away. So man's height 160 centimeter and source of light AB is 6 meter, the pole, and the rate at which it's changing is 1.1 meter per second. Now suppose that AL is equals to L meters. Here AM, sorry, this AM, please correct it. AM be ML meters and MS here be S, the shadow. So now it is given that the man is walking at the speed of 1.1 meter per second. So that means that this distance is increasing as he's walking away. This distance of AM is increasing, and that is dl by dt is equal to 1.1 meter per second, and let this be our first equation. Now therefore the rate at which the length of the man's shadow will increase, let that be ds by dt, as we have marked here in our diagram, so in our figure. So that will be ds by dt. So considering triangle ASB, so let me show you here ASB, the bigger triangle, when you consider that, so we can write that tan theta is equals to AB by AS, because tan theta is equals to what? Perpendicular upon base. So now we get tan theta is equals to 6, because here the perpendicular is 6 upon the base is what? L plus S, or you could write AM plus MS. L is the distance by which is increasing, and here this is the S is the shadow. So we write that. And considering triangle MSN, MSN is here, MSN, the shorter, the smaller triangle, and here again we write tan theta. So we'll get MN by MS, and let me show you MN by MS, which is 160 meter, or you could say 160 centimeter or 1.6 meters, correct this. And here MS is the shadow. So then the rate at which the length of the man's shadow increases will be ds by dt. And then again considering triangle ASB, we have written this. So now let this be our second equation. Now considering triangle MSN, we get this tan theta is equals to this and 1.6 upon S. Let this be the third equation. So far we've got 3 equations on hand. Let's look at the first equation, which is dl by dt. Second equation is of this one, tan theta is equals to, in triangle ASB, tan theta is equals to 6 upon L plus S. This is our second equation. And the third equation is in triangle MSN, which is tan theta is equals to 1.6 upon S. Now from equation 2 and equation 3, we can equate them because they are both equal to tan theta. When we do that, we get the value of S, or we get the value of L, right? So we get the value of S in terms of L, or vice versa. So now you can write L as 2.75 S. Then here, applying the derivative with respect to time on both the sides, now we're doing dl by dt, and here we got the value of L, so we can write that, right? Now dl by dt, and then you get 2.75 ds by dt, because 2.75 is the constant here which can come out. So basically the final expression is dl by dt is equals to 2.75 ds by dt. Now the value of dl by dt has already been given to us in the question as 1.1, so we substitute that, and then we get the value of ds by dt as 0.4 meter per second, which is our answer over here. Moving on to the next question, question number 7 says the radius of an air bubble is increasing at the rate of half, that is 0.5 centimeter per second. At what rate is the volume of the bubble increasing when the radius is 1 centimeter? So note that the air bubble is spherical, right? And r will be its radius and v will be the volume. So dr by dt has been given to us as half centimeter per second. Now we need to calculate the rate that is the volume of the bubble increasing when the radius is 1 centimeter. So that is, we need to calculate dv by dt when radius is 1 centimeter. Now we know that v is equals to 4 by 3 pi r cube for a sphere. Now we do dv by dt, and when we do dv by dt, we get the dv by dt value as this 2 pi r square. Now putting the value of r as suggested in the question, which is 1 centimeter. So when we put the value of r here 1 centimeter, we get 2 pi, and hence the answer here will be 2 pi centimeter cube per second. So the volume of the air bubble is increasing at the rate of 2 pi centimeter per second when the radius is equals to 1 centimeter. Question number 8. An edge of a variable cube is increasing at the rate of 5 centimeter per second. How fast is the volume of the cube increasing when the edge is 10 centimeters long? So let x be the length of the side and v be the volume of the cube. Now v for a cube is x cube, or the side cube, right? And here the side is x. So dv by dt we do, and then we get 3x square dot dx by dt by chain rule. This differentiation you know. Then dx by dt has been given to us as it has been given to us as 5 centimeter. I'm sorry, this is an error in the question, so you can correct that. Yeah, so dv by dt is equals to 3x square into 3. It should be 5, but okay. So assuming now that it's 3, so you get 9x square, and when x is equals to 10 centimeter, it is written here that when the edge is 10 centimeter long, so then you substitute the value of x, so that is 900, because the square of 10 is 100 and then into 9, so 900 centimeter cube per second. Now sorry for the error that in the question it is mentioned 5 centimeter per second, but the actual value we're using here is 3 centimeter per second, so you can correct that. But this is how it'll be solved, right, the method. Now, question 9. A balloon which always remains spherical on inflation is being inflated by pumping in 900 cubic centimeters of gas per second. So, dV by dt has been given to us as 900 centimeter cube per second. Okay. Now, find the rate at which the radius of the balloon increases when the radius is 15 centimeters. Now, when we're talking about a balloon, we will consider that it is spherical in nature, and it has also been mentioned here. So, the volume here for a sphere will be 4 by 3 pi r cube. Now, dV by dt is equals to dV by dr dot dr by dt, and here when we do that, we get 4 pi r square dot dr by dt. Now, the value of dV by dt has already been given to us, that is 900 centimeter cube per second. So, just substitute that and just solve ahead, keeping dr by dt as it is. So, dr by dt's value will be 225 upon pi r square. And we are asked the value of dr by dt when the radius is 5 centimeter, when the radius is 15 centimeter. So just put the value of 15 here, and then you get the answer as 1 by pi centimeter per second. Question number 10 says the radius of a circle is increasing uniformly at the rate of 5 centimeter per second. Now find the rate at which the area of the circle is increasing when the radius is 6 centimeter. So let the radius of the circle be r, and it is given to us that dr by dt is 5 centimeter per second. Now the area of the circle is pi r square. Just differentiate it with respect to t, so you will get 2 pi r dr by dt. Now when the value of r is 6 centimeter, so just simply put the value of the value of r as 6 over here, and then you get the answer as 60 pi centimeter per second square. Next question says, this is a very important question. It has been, I'm in school as well, and it has been asked me in all my school AOD tests, and just very important. So a 13 meter long ladder is leaning against a wall. The bottom of the ladder is pulled along the ground away from the wall at the rate of 2 centimeter per second. Now, how fast is its height on the wall decreasing when the foot of the ladder is 5 meter away from the wall? Now, the first thing that you should notice over here is the change of units, that over here the rate has been given in centimeters, while the dimensions of the ladder has been, all of that has been given in meters. So be careful with the units here. So now this is the diagram, and let AB be the ladder over here and OC be the wall, and this is the ground basically, right? So let OC be the wall, and at a certain instant t, let AB be the position of the ladder, such that OA is equals to x, the distance of the ladder from the ground. Let this be as x, and OB, that is the wall, let it be y. Now you could also take OA and OB, but just for your convenience, because we're used to practicing in x and y in those terms, so that is why we've taken them as x and y. Now dx by dt has been given to us as 2 centimeter per second, here, and we will convert that in meter first, because all the other dimensions are in meter. So that dx by dt we'll get as 0.02 meter per second. Now from Pythagoras theorem, we can write that x square plus y square is equals to 13 square, right? And let this be our first equation. Now differentiating this very Pythagoras theorem, this expression that we've got using Pythagoras theorem, equation 1 को let's differentiate with respect to t. And when we do so, we get the value, we get this expression as 2x dx by dt plus 2y dy by dt. And since 13 is a constant over here, so of course its differentiation will be 0. So 0. Now putting the value of dx by dt that we've been given in the question, so here we put the value, and we get this dy by dt is equals to minus 0.02 x by y, and let this be our second equation. Now if x is equals to 5 meters, which has again been given to us in the question, the value of y will be under root 13 square minus 5 square. And how did we get this value? From Pythagoras theorem expression, and this value is 12. Now putting the value of x and y in equation 2 again, finally we get dy by dt as minus 10 by 12 centimeter per second, and you can further simplify it and write it as minus 5 by 6 centimeter per second. Now if you're confused why are we putting the negative sign over here, because the it is decreasing, right? Whenever something is decreasing, the rate will always be in minus. So that is why. Question 12. Water is leaking. Now this is again a very important question. So water is leaking from a conical funnel at the rate of 5 centimeter cube per second. If the radius of the base of the funnel is 5 centimeter and its altitude is 10 centimeter, find the rate at which the water level is dropping when it is 2.5 centimeter from the top. So according to the given question here, the diagram will look something like this. We have been given that it is an inverted conical funnel, and when you're talking about a funnel, of course it will be in this shape, right? And we have also been given that its total height is 10 centimeters, and the radius of the base is 5 centimeter, right? So this is given to us, and now we've been asked that the rate at which the water level is dropping when it is 2.5 centimeters from the top. So from the top, this distance will be 2.5, and here this will be h. So let r be the radius and h be the height of the surface of the water at time t, and let v be the volume of the water in funnel. So v for a cone we know it will be 1 by 3 pi r square h. This is our first equation. Now from the figure itself, from this figure by geometry and all, we can say that r by h here will be equal to 5 upon 10. R upon h will be 5 upon 10, correct? So according to that we can write r is equals to half h. Now substitute and let this be our second equation. So substituting the value of r here in the first equation, we get this as pi h cube upon 12. This is the value of volume. Now water is running out at the of the funnel at the rate of 5 centimeter cube per second. That means dv by dt has been given to us as 5, and since the water is decreasing, that is why we will write minus 5. So d by dt is then you write the volume here, the value of volume here, that is this, and equal to minus 5. Now differentiated with respect to t, and you get this expression, and you get dh by dt also here, right? Now dh by dt, when you further solve it, you get minus 20 upon pi h square, and because it's that, so we can write this. Now at time t has been given to us, and the water level is 2.5 centimeter from the top. That means we have been given the value of h, and h 10 minus 2.5, because the total height is 10, and we've been given that we're talking about 2.5 centimeter from the top. So that means the total height of the water will be 10 minus 2.5, that is 7.5. And then we put this value of h here in this expression, and we get the value as minus 16 upon 45 pi centimeter per second, which is the answer to this question. Next question. Two equal sides of an isosceles triangle with fixed base B are decreasing at the rate of 3 cm per second. How fast is the area decreasing when the two equal sides are equal to the base? So this is a triangle ABC, which is an isosceles triangle where BC is the base here and AB is equals to AC. These sides are equal since it's an isosceles triangle. And let them be A, and let BC here be H. Okay. Now the length of the two equal sides of triangle ABC are A, and we have drawn a perpendicular to BC, that is AD. AD is the perpendicular to BC here, and it divides BC such that BD is equals to DC, that is both are H by 2. Now in triangle ADC, by applying Pythagoras theorem, where is triangle ADC? See, ADC. In triangle ADC, we apply Pythagoras theorem. So what will we get? We get AD is equals to under root of A square minus B square by 4. The area of the triangle, we know it is half into base into height, and AD here is the height of the triangle. So substituting all these values, and then we're supposed to the rate of change of area with respect to the time t is given by. So dA by dt we do, and when we do dA by dt, the value we get is this. We get this expression that AB upon root 4a square minus 4b square dot dA by dt. Now it is given that the two equal sides of the triangle are decreasing at the rate of 3 centimeter per second. So the dA by dt has been given to us as 3 centimeter per second. Substituting the value of that, and then when a is equals to b, we have this. So basically we can write a as b or b as a, so both your choice. So 3 minus 3b square upon root 3b square, and we get minus root 3b as the answer. So hence, if the two equal sides are equal to the base at that very time, then the area of the triangle is decreasing at the rate of minus 3b centimeter square per second. And the last question for today, question number 14. Water tank has a shape of an inverted right circular cone with its axis vertical and vertex lowermost. Its semi-vertical angle is tan inverse 0.5, that is tan inverse half, and water is poured into it at a constant rate of 5 cubic meter per hour. Find the rate at which the level of the water is rising at the instant when the depth of the tank is 4 meters. So let the radius and the height of the cone be r and h respectively, and let the semi-vertical angle be alpha. So here is the diagram according to the question. This is the inverted right circular cone, and let this be the height, and this is the radius. And the when we talk about the semi-vertical angle, this is the angle we're talking about, and this angle is alpha, and the value of alpha is tan inverse 0.5. That means you can simplify it, and you can write it as this. Now tan here, tan, we can write the value of tan as r by h, right? In this triangle, if you see this triangle that I'm marking here with the cursor, in this triangle the value of tan alpha can be written as this r by h. So therefore we get r is equals to h by 2. Now it has also been given to us that the volume is changing with respect to time as 5 meter cube per hour. Here v is the volume of the cone, and volume of the cone we know is 1 by 3 pi r square h. So when we when we substitute the value here of radius in terms of h, and we get the volume only in terms of h, then finally we differentiate with respect to x and with respect to t, and we get this, that is 5 is equals to 1 by 4 pi h square dh by dt. Now dh by dt is equals to 20 upon pi h square, and then it has been given to us in the question that they're asking us the rate of change of the level of water. So this they're asking us when the depth of the water in the tank is 4 meters. So then you put h is equals to 4, and then you get dh by dt as 5 upon 4 pi. Now if you want, you can also substitute the value of pi as 22 by 7 here. Don't put 3.14. Since we're talking in fractions, everything is being dealt with in fractions. So then put the fractional value of pi, that is 22 by 7. And when we do so, we get it dh by dt value as 35 upon 88. And therefore our answer here will be 35 upon 88 meter per hour. Now even if you did not substitute the value of pi, you should get marks ideally, but it is always better to do so whenever pi up comes in the question. So that's it for today, guys. I hope you all understood very well. These are the top 14 questions for 8 measurements questions. So yeah, bye.